Hello everyone. In this video, we will be covering the ratio and the root test, which corresponds to section 11.6, and we also talk about 11.7. So the ratio test is one of the most powerful tests in calculus and in math in general, and it will be one of the ones that you will use the most in the coming classes. You have to take more classes. So the ratio test says the following. Uh, if you have a series with positive terms, and then you take the absolute value, so this is actually going to be called also absolute convergence, and we'll talk more about that a little bit later too. So you take the limit of the ratio, that's why it's called the ratio test. If you get a number that is less than 1, then the series converges absolutely. If it is more than 1, then it diverges. And if it is equals to 1, it's inconclusive. So if it is inconclusive, that means you need to use another test, which you have a choice. It could be like the integral test, comparison test, and so forth. Okay? But let's start with this one. Let's do an example. So here, an is equals to n e to the minus n, which, since we're going to use fractions, it may be easier to rewrite it like this. Notice that this is exactly the same thing as this. So that's an. So therefore, an plus 1, you replace just the n times n by n plus 1. So in this case, this will be n plus 1 divided by e to the n plus 1. Now, recall from algebra 1, algebra 2, pre-calculus, whatever, that e to the n plus 1 is the same thing as e to the n times e, just in case you forgot. So therefore, if you do the ratio of an plus 1 over an, this will be the ratio of n plus 1 over e to the n times e. And remember, when you divide fractions, you have to multiply by their reciprocal. So this will give you this. Why? Because you have a over b divided by b over c. Remember, this is equals to ac over bd. Okay? So recall these two things. So therefore, you simplify this. Notice that this will cancel this, and you'll end up with just n plus 1 over n times e, or e times n. So therefore, if you apply the ratio test, so we need the limit as n goes to infinity of the ratio. Also notice that for this particular problem, there is no need to use the absolute value because everything is positive. But then you're just finding the limit as n goes to infinity of n plus 1 over e times n, or a times e. Now notice that this is a limit that you learn, or this kind of limits you learn in calculus 1, and you sometimes you might have to use L'Hopital's rule. That's not the case for this one. Notice that the degree for this one and this one are the same, so therefore the limit is just the ratio of the two coefficients. So in this case, it will be 1 over e, which is clearly less than 1. So therefore, this is absolutely convergent. And remember that I will use this symbol for convergent by the ratio test. Okay? Now, one thing that's going to be very important, so note, if a series is absolutely convergent, then that implies convergent. But convergent doesn't imply, does not imply absolutely convergent. Okay, so the opposite is not true, and we'll get to that later. All right, let's try another example. By the way, anytime this series involves a factorial, you should always use the ratio test. Okay, so let's start with what is an. So notice that an is equals to n factorial over n to the n. So therefore, an plus 1 is going to be equals to n plus 1 factorial divided by n plus 1 to the n plus 1. Now here it's very important to simplify this before you attempt to cross anything out. Remember that n plus 1 factorial from pre-calculus is the same thing as n plus 1 times n factorial. And n plus 1 to the n plus 1 is the same thing as n plus 1 to the n times n plus 1. So this is actually very, very important to simplify before you attempt anything. So therefore, if you do the ratio of these two, this is what you end up with. So this should be n plus 1 times n factorial divided by n plus 1 to the n times n plus 1. And then, remember, since you are dividing, you multiply with the reciprocal. This will be n to the n, and this will be n factorial. Okay, again, there's no need for the absolute value because everything is positive. But here, you can tell right away the n plus 1 will cancel this n plus 1, and this n factorial will cancel this n factorial. So therefore, this will simplify to n to the n power divided by n plus 1 to the n power. Now notice how these two have the same power. So you can rewrite this as a single power. So it should be n over n plus 1 to the n. Now, before we take the limit, there is something very important to remember from Calculus 1. So recall this from Calculus 1. And to get this result actually requires L'Hopital's rule. But this is one of the most important limits in Calculus 1. The limit as n goes to infinity of 1 plus 1 over n to the n is equals to e. Well, remember, e is the irrational number, which is equals to 2.171 and so forth. Okay? So this is the case. So therefore, notice what we have here. You have n over n plus 1 to the n power. Notice that this is equals to n plus 1 over n to the negative n. Why is that true? Because 3 over 5 square is the same thing as 5 over 3 to the negative 2. And the only reason why we want to do this is because we want to use this limit. Okay? Otherwise, you're going to have to use L'Hopital's rule and do the whole thing from scratch. So therefore, if that's the case, then if we apply L'Hopital's rule, the ratio test, then we have that the limit as n goes to infinity of the ratio is equals to the limit as n goes to infinity of n plus 1 to the divided by n to the n power. But based on this is equals to the limit as n goes to infinity of n plus 1 to the n to the negative 1, which if you rewrite this is the limit as n goes to infinity of 1 plus 1 over n. Why? Because this n over n gives you 1, and it will give you 1 over n to the minus n. And if you go one step further, this is the limit as n goes to infinity of 1 over 1 plus 1 over n to the n power. But notice that this is exactly this. So therefore, in this particular case, the limit is exactly equals to 1 over e, which is less than 1. So therefore, this is absolutely convergent, which means it's convergent by the ratio test. Okay. All right, so let's try another example. Remember that anytime you have the factorial or a bunch of multiplications like this or products, the best choice is the ratio test. Okay, so in this case, we have the a n is this. In this case, you do have a negative value, but since we're going to take the absolute value, so it doesn't matter. So therefore, you have a n is technically 2 to the n times n factorial over 5 times a times 11 times that times 3n plus 2. Okay, so here you have to be careful what is the next value. So therefore, an plus 1 is going to be 2 to the n times 2, because remember this is 2n plus 1. And actually, let me write that. This is 2n plus 1. You replace n by n plus 1. It should be n plus 1 factorial. And then on the bottom, this should be 5 times a times 11, that 1, 2, 3, then that 3n plus 2. And then the next value is going to be 3n plus 1 plus 2. So this is the part that many people usually miss. And then if you simplify, notice that this is 2 to the n times 2. We have done that a few times. We already say this was n plus 1 times n factorial. And on the bottom, the only thing you can say is that this is 3n plus 2. Sorry, plus 3 plus 2, which should give you 3n plus 5. Right? So therefore, when you do the ratio, so therefore from here, an plus 1 over an, this will give you the following. So this is going to be 2 to the n times 2, n plus 1 times n factorial, divided by 5 times a times 11 times 3n plus 2 times 3n plus 5, and then times 5 times a. Remember, you had to multiply with the reciprocal, and then times 3n plus 2. Then on the bottom, this is 2 to the n times n factorial. Okay, and notice here the 2n cancels the 2n, the n factorial cancels the n factorial, and then all of this will cancel up to here. So therefore, this simplifies to just 2n plus 1 divided by 3n plus 5. So therefore, you apply the limit. So the limit as n goes to infinity of the ratio is just equals to the limit as n goes to infinity of 2n plus 2 over 3n plus 5. Now, again, notice is the degree of this one is 1, the degree of this one is 1. The limit is just the ratio of the two, or you can just also use L'Hopital's rule. So this is 2 over 3, which is less than infinity. So therefore, this is absolutely convergent by the ratio test, which means it's also convergent. All right, so now let's look to the root test. The root test has technically the same statement as the ratio test for this part. The big difference is for the ratio test, you take just the n root of the absolute value by n, but this part is the same. Okay, so let's do this example first. This is the exact same example that we did with the root test, but now we're going to use that we do with the ratio test, and now we will do the root test. So here again, an, notice that is equals to n e to the minus n, which is the same thing as just n e to the n. Okay? So therefore, you take the n root of the absolute value of that, it will be technically just n over e to the n to the 1 over n. Why? Because remember that the n root of x is equals to x to the 1 over n. So that's from algebra. Okay? So notice that you can simplify this as n to the 1 over n divided by just e. Okay? And then you recall from calculus 1. So this is from calculus 1. And you may want to recheck this using L'Hopital's rule that the limit as n goes to infinity of n to the 1 over n is equals to 1. So for this, you usually need L'Hopital's rule to check that's the case, okay? But for our purposes, we can just use the result. So this is what we have. So therefore, the limit as n goes to infinity of the n root of the absolute value of n is equals to the limit as n goes to infinity of n to the 1 over n divided by e. Since this is a constant, you only have to worry about this part, but the limit of this from calculus 1, or you can use L'Hopital's rule again to recheck, is equals to 1. So this is essentially 1 over e, which is less than 1, and therefore, again, is absolutely convergent. Okay. Just for the record, if this would have been backwards and this was, let's say, e over 1, so that would be more than 1, and therefore it would be divergent. Okay. All right, so let's do another example. So here we have minus 2 to the n, and therefore here an is equals to minus 2 to the n over n to the n power. Notice that you can rewrite this as minus 1 to the n times 2 to the n over n to the n, okay? So therefore, if you take the n root of the absolute value, this will just give you 2 to the n, okay? So therefore, if you apply the limit, so the limit as n goes to infinity of the n root of the absolute value, this will be the limit as n goes to infinity of just 2 over n. But the limit of this is clearly equals to 0, which is clearly less than 1. So therefore, this is absolutely convergent by the root test now. And that's it. Now, what about if this test gives you a inconclusive result? What do you do? So, for example, let's say that you want to figure out what this is using the ratio or the root test. So let's do ratio test first. Okay, so let's say you do the ratio test. So we do the ratio test. Notice that an is 1 over n squared. So therefore, an plus 1 is going to be n plus 1 squared. Okay, so therefore, if you do the ratio of an plus 1 over an, this will give you n plus 1 squared over n squared. But the limit as n goes to infinity of n plus 1 squared over n squared is equals to 1. Why? Because remember, this is equals to n squared plus 2n plus 1, and they have the same degree, and the coefficients are 1 and 1, so therefore the limit is 1. So therefore, since this is equals to 1, that implies this is inconclusive. But inconclusive, that doesn't mean there is no solution. That means you cannot use this test to do it. So therefore, if the ratio test fails, then you can see that, okay, well, so notice this is actually a P series where P is equals to 2, which is bigger than 1. So therefore, this is convergent by, technically it's the integral test, but you can just say it's a P series, and that's it. The same thing will happen to this problem if you use the root test. So let's say we have the exact same problem, and you use the root test, then notice that the n root of the absolute value of an, it will be equals to this, to the 1 over n, which will give you 1 over n to the 2 over n. And notice that the limit as n goes to infinity of this is also equals to 1. So again, is inconclusive, should be conclusive. So therefore, you need to use a different test, which again, you can just mention this and so forth. All right, so that's it.